This is my Bendix G15, and it's been a hot minute since we've had this on the channel, and there's a really good reason for that, and I'm going to get into that in just a second. But first, this machine is an incredibly historically significant machine that was designed by Harry Huskey, who had worked with Alan Turing on the Pilot Ace. There's a wonderful amount of history here tied up in this machine, which raises the question of how did it get here in this room? Well, this particular machine is on loan from Bob over at System Source Museum, and if you haven't heard of System Source Museum by now, what are you doing, man? It's like one of the greatest computing history museums in the country, and it's working on becoming one of the greatest computing history museums in the world. He has an unbelievable collection of gear there, and a lot of it works, and you can get hands-on with a lot of really unique things. So go check out System Source Museum, and if you do, give Bob a high five for me because Bob is an absolute legend. And well, Bob actually has two of these Bendix G15s, so he was kind enough to send one all the way down here to Texas so we can try and get it going. And if we do get this thing up and executing code, it may very well be the oldest running digital computer in North America. That's pretty exciting. So we are right at the cusp of pushing this big green button here that brings DC up and gets it to the point of executing code. In the previous episodes, we got right up to that point, and I kept saying in the very next episode, we're gonna push that button, and then 2 months went by. And no, I'm not scared of it. No, I'm not worried that something broke on it or I haven't forgotten about it. There's actually a very, very good reason why it's been so long since we've dug into this, and that's because there's been somebody behind the scenes that's been helping me out. And I'm gonna bring him on camera here. So Lloyd, why don't you come on over here? So Lloyd, tell the people who you are.
I'm Lloyd. I live about 2 hours from here. I have one of these machines in my garage that, like David, I'm restoring as well. So we've been helping each other. And I used to program and repair these machines back in the 70s.
So yeah, there you go. Lloyd has been absolutely instrumental in getting this machine to the point that it is right now, to the point where we're ready to push that button. And I really wanted Lloyd to be here for this moment, partially because I don't really know what I'm doing and I want him here to help me out, but also this is a pretty monumental occasion and it wouldn't feel right to do it without Lloyd here. And unfortunately, Lloyd had injured his foot, so we had to put things on pause until his foot healed. But as you can see, Lloyd is here, standing on his own 2 feet again, so we're gonna push that big green button today. There's a couple of things that we want to double check before we do it, but this is the big one. I'm really excited about it. I think I've exhaustively gone through just about everything needed for a first power-up, except for the main DC smoothing caps. And as you can see, there are a lot of these beasts tied in parallel here. Fortunately, it's pretty easy to get them out to inspect, and these old Sprague caps, in my experience at least, have been remarkably reliable, proving to still be rock solid even 60 years later. So all I'm gonna do is check them for shorts. The first string here is coming in at 86 ohms, which seems about right to me, given how much power some of the DC rails pull. The next string is clocking in at about 130 ohms, which again seems totally fine. The next group is a small group of just 4 caps, and it's coming in at 5 ohms. That's a little low. Let's check the next group, which is also a small group of 4, and it's coming in at about 3 ohms, which is also a little bit low. The final collection here is at 270-ish ohms, so I think that's probably okay, but those two that we measured at 3 and 5 ohms are a little concerning. Let's see if we can figure out what they are, and maybe we can figure out if that's normal or not. And fortunately, I can reference the parts manual and see that those two are labeled C5 and C6, which are 25 volt 1000 microfarad caps. So the good news is that if they're bad, they should be relatively easy to replace. But let's check the power supply schematics just to be sure. On this schematic, we can see that C5 goes between negative 13 volts and 0 volts, and C6 between negative 20 volts and negative 13 volts. Interestingly, between negative 20 volts and 0 volts are resistors R12, R13, R29, and R30. And looking in the chart in the bottom, R12 and R13 are 4 ohms, but weirdly R29 and R30 aren't listed here. Also, these are variable resistors, so they may not even be adjusted to the full 4 ohms. Given that R29 and R30 are in series with R12 and R13, I think we can venture a guess that they're of a similar resistance value. So the values we were seeing before of 5 ohms and 3 ohms actually sounds about right for the resistors that are in parallel with those caps. And since we weren't seeing less than 1 ohm, I'm willing to bet the caps are totally fine. Honestly, I think we're totally fine to just send it here. All right, I think we've done our due diligence. The capacitors are definitely not shorted, and I think they're gonna come back to life no problem. Everything looks like it's pretty much ready to go to flip the big switch. So let's start with bringing AC up. We've done this before. All we gotta do is flip this big switch right on the front here. All the fans have come up. My little strings here will float if you get them aligned correctly. We should hear 3 total clicks while AC comes up. This is a soft start to essentially warm the filaments up. It takes it a little bit of time though. There was the first click. We can see that we're getting just a little bit of glow out of our AC light here, and our AC percentage voltage is still down at about 70%. The second click should be coming shortly. There was the second click. That puts us at 100%. We'll adjust this guy right on down to be 100% perfectly. Our AC light is on. There should be a third click coming that'll tell us that AC is fully up. There we go. All 3 clicks are up. AC is fully up. All 5 fans are spinning. The rotating drum is up and going. I think we're ready to go. I think we're ready to push that big green button.
Go for it.
You ready to go? All right. We're hoping that something happens. If nothing happens, then we got a different problem. But here goes nothing. It's doing stuff. I don't know what it's doing. We got a little bit of DC for a minute there, and then it went away.
And the light up here came on.
What light up where came on?
Tape reader.
Okay.
Oh, here it goes again.
Yep. There it goes. So we get a clack, and then it immediately cuts off. All right, so what happened? That probably looked a little chaotic since we have so many different cameras going on, and we were really kind of confused about what was going on ourselves. It almost worked, but it didn't. Whenever we pushed this reset button, it just clicked on and clicked off immediately. And it did that every time we tried it, and it takes a while for that reset button to reset, because I think the sequencer has to make a full rotation. So we've got something wonky going on, but it is so close to coming up. We saw so many things go right that, honestly, many more than I was actually expecting to go right. So this is fantastic. But we've got the manuals out. We're gonna dig through it and see if we can find anything that might be holding us up. I think the first thing to do is to check the fuses. Okay, right on the back of the machine here, we have a row of fuses. Looks like about 8 or 10 so here. And I was going through and checking these and expecting, pretty normal stuff. Like if I check this one, we should have, looks like maybe 1 ohm. It's probably bad connection on my probes there. We're getting below 1 ohm. That's probably totally fine. But when I checked fuse number 12 here, that's like 470 ohms. That's more than just like a bad connection on my probes here. Something is certainly not right with that particular fuse, because the rest of them all look like a normal fuse. So number 12 here is a little suspect. So I think we're gonna pull that out and we're gonna take a look at the schematic and see which fuse in particular that is, because that could be causing our problem. Let's dive back into our schematic to find out what fuse F12 is. And it's over here on the right as part of this huge group from F7 to F12, which all make up the plus 100 volt lines. This absolutely could be causing startup problems. Now, fuses can just get old and break, and these fuses are likely 50 plus years old, so hopefully that's what we're looking at here. I'll pop a new fuse in, but this power supply is designed with a lot of protection. Aside from all the individual fuses here, we also still have fuse F2, which should protect the transformer, which I would argue is the most difficult to repair or replace component on the whole machine. With the fuse out, check this out. I've got a new fuse right here, and if I touch the probes across it, exactly what we're expecting, 0.2 ohms, which is probably just the internal resistance of my probes here. But if I check the fuse that I pulled out, do the same thing. I'll just put the probes right across it here. There we go. That looks like a blown fuse, and that would absolutely keep our DC from coming up. So we'll replace this fuse and give it another shot. All right, we got the new fuse in. Man, hopefully this fixes it. I don't think I'm that lucky, but who knows? Stranger things have happened. We've got the AC fully up. It's pretty much ready for us to push the reset button. There is a very large relay that I've got Lloyd keeping a close eye on. I've also got a camera over there looking at it as well. This is the K3 relay. Pretty much all of the DC interlocks run through this relay. So if this relay is not actuating, then we know that we've got some DC interlock problem going on. Hopefully we see some movement out of that. So I think we're ready to push that button. Lloyd, you want to do the honors? There it goes. Yeah. I saw K3 move. We got the DC light on the front here.
And it stayed.
And it stayed. Okay, so yeah, so the processor's halted. We're at some destination. We got lights going on. What's the next step? We hit reset again to see if ready comes on?
The I/O should have engaged.
So the I/O didn't engage.
But everything's off, so that's a problem. We did not see this turn on,
No, the light never kicked on for it either.
but we're progressing.
Yes.
So that's good. So,
Progress.
much progress, right? We got power.
Okay, we're powering on, but we're not booting up. I don't think booting up is the correct phrase to use here, given how strange the system is, but whatever, that's the word that I'm gonna use. But after spending about 5 to 6 hours with Lloyd yesterday, pouring through the schematics, the documentation, the simplified diagrams, I think we're starting to figure out what's going on. And we're gonna have to get pretty deep into the system, but let's go ahead and start at the highest level possible. And that's the approach that a user would take with this system. And it's actually pretty simple. You turn on the big start switch on the front, you wait for 3 clicks to go and AC to fully come up. Then you push the green reset button. And when this happens, the red DC on light should come on. The paper tape reader should automatically start reading in a number track, and when that's finished, the green ready light should come on, and then the system is fully booted up and ready to use. Now, we're losing the plot somewhere in the middle of that, because when we push the green reset button, we get the red DC on light, but we never get the green ready light, and the paper tape reader never actually kicks off. So if we look at the diagram here in the manual, we actually have a full view of what happens during the entire boot up process. When you flip the big start switch on, that turns AC on, and TM1, which is a little sequencer, kicks off. And when it does this, it essentially slowly brings up the filament voltage over the course of about a minute. And it does this in 3 stages until the filaments are fully warmed up and the whole machine is ready to go. That takes us up to this little dashed line right here. Then you push DC reset, and this kicks off TM2. This is another sequencer, and it rotates at about 6 times the speed of TM1, so this all should happen very quickly. And then some interesting things happen down here with the internal logic of the machine. It clears some stuff out, so it sets OCs to 0000. Then we clear the number track. Then we reset CG and we establish TO on the number track. And then we get to this line, which I think is probably the most important one for us, that's called auto tape start. And it sets the OCs to 1111. After that, we do some other stuff with setting M19 to the number track, and then we clear the OCs back down to 0000, and we're good to go. The ready light comes on, and we're off to the races. But we're never kicking off the tape, so auto tape start is clearly not functioning. But it is functioning because it's mechanically controlled. It's a wafer switch on a little servo motor, and I can visually see it. I've watched it spin multiple times, and I've even gone through and checked to make sure that all of the contacts are working. And if we look at the little diagram over here on the left, we can see that wafer switch drawn out. And if we follow auto tape start in, there it goes to pins 6 and 9, and that wafer switch goes through and actually grounds those pins out twice. So if we look over down here, it shows what the state of the OC should be, and it's 0, 0, 0, 0, and then they all go to 1s, then they all go back to 0, then they all go to 1s, then they all go back to 0 again. So when they're at 1s, that's when that wafer switch is hitting 6 and 9 and grounding that pin out. And I've checked this with the multimeter, that's working perfectly. Now the OCs is interesting. This is a collection of flip-flops. So if we look at this page here, this shows OC 1 through 4, and we can see that they are actual just flip-flops. So we actually have some logic going on here. We're having to deal with packs on the doors at this point. But I don't even think we're getting as far as the OC logic, because if we follow the auto tape start signal that's coming in from the left, it goes into an OR gate here that is with P and SA, and then it goes through tape start to another OR gate, and then that finally goes through and sets all the OC flip-flops. So we decided to start checking right around here to see if that auto tape start signal was actually making it all the way in. And it is. That auto tape start signal is pulling something to ground, but the trouble is that they should be at -20 volts, and they're not. So yes, when the auto tape start hits, it grounds those out, but the rest of the time it should be at -20 volts, and it's not. It's floating up to about +4 volts. And that is very wrong and would absolutely stop all of this from working. So that's where we're losing the plot. It's right in here. Now what's interesting is that that -20 volts should be coming from the SA line. That should be pulling it to -20. So what is the SA line? And well, that's a really good question, and you can look through a bunch of these and you would never find it because it's not actually on the machine. You have to go over to the typewriter. So the SA line in the typewriter is pulled to -20 volts through a 1 kilo ohm resistor, and when you flip the enable switch, it grounds that out, pulling it back up to ground. But what we are seeing on the machine is that the SA line is sitting at +4 volts. So something in the typewriter is dramatically wrong, and it's preventing the Bendix from starting up. Now, we took a look at the typewriter in a previous episode, and I mostly just focused on the mechanical side of things. I wanted to get it working as an actual typewriter, and we did get there. It works fantastically as a typewriter, but the Bendix electrical control interface portion of it, I didn't dig into because I didn't know how to test or check any of that without having it plugged into the machine. And I figured once we plugged it in, that would illuminate any faults, and well, faults have been illuminated. So we're gonna have to dig very deeply into the typewriter in the future to get it going so that we can finish our boot up process on the Bendix. But here's the thing, the Bendix wants to run. This thing is raring to go, and I can actually show that to you because we were playing around on the engineering panel that's on the inside there, the diagnostic panel that's on the inside there, and we discovered some pretty interesting things. So let's spin this thing up one more time, and I got some cool stuff to show you. All right, here we are, fully spun up. DC is on, but the ready light hasn't come on yet because we still have that fault in the typewriter. And I am on my little diag panel here that allows me to test a bunch of different things. I've got the scope probe hooked up into this scope signal port here, and then wherever I plug this little lead here into the plug board here allows me to check that on the scope here. And currently we're on NT, and you can see the scope is totally flat, but watch this. If I hit this button over here, now we have a signal. And if I shorten up the time base here, you can see we have a very precise pulse that I just wrote down onto the drum using my little test over here. If I click the clear, my signal goes away. If I set it again, boom, there it is. How awesome is that? We are writing stuff to the drum and reading it back effectively. If we go over here to L0, you can see we've got more signals going on here. I can take a scope shot of that and it's very weird looking. Same with L1 here. Just tons of stuff going on. And all of this is signals that is not available anywhere else. This is stuff that is being laid down on the drum and read back out. That means that our write amplifiers are working, that our read preamps are working, that our read amplifiers are working, and that a large amount of the logic is properly functioning. This machine wants to run. Most of the signals on the plug board here have something going on. OZ has a really slow pulse on it, so maybe that's once every revolution. This is just crazy exciting. T29, this is an actual track. This is track 29. We are writing pulses down and reading them back. Everything is working. This machine wants to go. As you can see, we have signals being laid down on the drum and read back out. A colossal amount of logic in the doors has to function for that to actually happen, and here it is happening. This machine is so close to just working. This is unbelievable, and I think at this point, this is the closest to a fully functioning Bendix G15 anywhere in the country, perhaps anywhere in the world. This is fantastically exciting. The only thing that is holding us up is the typewriter, and we could have one of two issues going on. There were several different revisions of typewriters, even for the numeric machines like this, and this could be for a different revision, so maybe some of the pinouts on the plug aren't quite right. Or, well, as we saw in the previous episode, the logic portion of this typewriter is in pretty rough shape. Some diodes have been jumpered across, some resistors have been lifted, and I honestly couldn't even find out where the negative 20 volts is supposed to be on there. So we're gonna have to dig in really deep on that typewriter, and I'm afraid that's gonna take a bit of time and a lot of tedium to figure out exactly what catastrophe happened inside of it that resulted in the condition that it's in. But once we get that typewriter going, this machine should load the paper tape in and start executing code, which would technically make it the oldest running digital computer in North America. So we didn't quite get to that milestone today, but we're definitely getting to that milestone in the next episode. I am so glad that Lloyd was able to be here for this initial bring up, even though we didn't make it all the way. It was absolutely worth the wait to have his expertise here and to have him just be a part of that experience. So Lloyd, thank you so much for coming down, and thank you so much for all the help you've given so far. We are absolutely going to get your machine up and going soon as well. This is an exciting project. I am just absolutely pumped. So I want to thank you all so much for watching, and I hope to see you in the next episode.